Bismillah, this video to answer the free response for Unit 5. Please read the question. Part A, we need to draw the forces acting on this disk. For this disk, we have two forces. We have gravitational force, of course, from the center of the disk, Fg. Also, we have the torque because of the string here. So this string will cause torque on the left side of the disk. So, and of course, this torque will be upward, right? So this is Ft, torque. Second part is asking about the relation between Fg and Ft. Read it, please. Now, we need to also to justify our answer. Let's start with with justifying the answer, then we will choose the answer. Now, since it is falling down, that means the forces downward is greater than the forces upward. Start at rest, the object start at rest and then fall down. That means the acceleration is downward. That means net force is downward. So, since net force is not zero and it's falling down, that means Fg is greater than Ft. So the answer is Ft is less than Fg. And justifying our answer, this is the justification. Part C, express our answer in M and R. We have three parts of this question and we need to derive. For first part, we need to derive an expression for the acceleration A, the linear acceleration of the disk. Okay, let's start. F net equal M times A. F net is Fg minus Ft equal M times A. Now, here, let me stop and explain something. Why we chose to write Fg as positive and Ft as negative? Actually, because Fg and the acceleration both are downward, so we chose to consider downward direction as positive direction. Is it right to consider the upward direction as positive direction? Yes, of course. And both solutions will give us same final solution. Anyway, let's continue. Fg is M times G minus. Now, what is Ft? We don't know. Actually, here we have two unknowns, Ft and A. Of course, everything is unknown, but remember that M and R considered as part of the solution. So here and any other physical constant. So M considered as given, G considered as given, Ft is not. So we need to find another equation that helps us to find Ft. Actually, the only thing comes to mind is the net torque equal I times alpha, the rotational form of Newton's second law. What are the forces here? We have Fg and Ft. But which one of them, or what is the torque of each one of them? Fg has zero torque. Torque G equals 0 because R is 0. It is going through the axis, or the rotational axis. So torque is 0. Now, for the other one, this is the radius. So tau T equal Ft times R. Now let's go and use this. Ft times R equal I, which is 1 over 2 mr squared. Of course, this is given in the question. Okay. Okay, now let's use this and now multiply by the alpha. Alpha is, we know that A equal alpha times R, alpha equal A over R. Of course, don't forget that A is linear acceleration, alpha is rotational acceleration, and R is the radius. This is very important to understand. So instead of alpha, we write A over R. R with the squared cancelled. The other R with the R on the left cancelled. Now Ft equal 1 over 2 MA. Take this and use it here. Now 1 over 2 MA equal MA. Of course, all of them are the same mass. So small masses. Okay. Don't forget that we are trying to find A. Now, mass will cancel each other. G equal A plus 1 over 2A. G equal 3 over 2A. Now we need to find A. So A equal 2 over 3G. This is the final answer for the first part. For the second part, we need to derive an expression for the time delta T that takes the disk to reach the ground. To reach the ground, the disk should fall 3R, right? So it should fall 3R to reach. So delta Y equal 3R. So we can use one of the kinematic equations. Delta Y equal V initial times time plus 1 over 2 AT squared. Delta Y is 3R. V initial is 0. Multiply by T, 0. Plus 1 over 2. The acceleration is 2 over 3G. It is from here. Okay. Multiply by T squared. 2 with 2 cancelled. Those cancelled. Now take 3 to the other side. It will be 9R equal G T squared. 9R over G equal T squared. T equal radical 9R over G. That's equal to 3 radical R over G. Of course, 9 can be found. The radical 9 can be found. So we take it outside. So this is the answer. For part 3, we need to derive an expression for rotational kinetic energy K rotational of the disk at incident it reaches the ground. So what is the kinetic energy when it reaches the ground? The kinetic energy when it reaches the ground equal to 1 over 2 I omega squared. What is the velocity when it reaches the ground? And what is the rotational inertia? طيب, the rotational inertia is 1 over 2 times mass times r squared. As we said, it's given. Now, what is omega? We know that alpha equal change in omega over change in time. Omega at the beginning was 0, so omega final minus 0 over time. Then omega equal time times alpha. So instead of omega squared, we can say it's delta t squared times alpha squared. What is alpha? Let's separate here this side. Alpha equal A over R, as we said at the beginning, right? Yes, here. Alpha equal A over R, so we can substitute that. K equal 1 over 2 times 1 over 2 is 1 over 4 m r squared delta t squared A squared over R squared. R squared with R squared cancelled. Time, we found the time to reach the ground. This is the time. So now let's substitute it. K equal 1 over 4 m A squared. Now, T squared is 9R over G. We removed the radical and squared the 3 because we had time squared. So we used this one. We removed the radical because T squared. We squared the 3. It's 9 now. Okay, let's continue now. We need just to okay. Hey, and the acceleration also, we found the acceleration here. The acceleration equal 2 over 3g. So also we substituted 1 over 4 m. The acceleration is 2 over 3g squared. We have acceleration squared. So the acceleration squared is 4 over 9 g squared, right? 4 over 9 g squared times 9 times r over g. Now, cancel. So the squared with g. K equal mg times r, and this is the rotational kinetic energy. Thank you for watching, and inshallah